Oke, ubah dulu jadi video. Nah nih, ini maksudnya apa ya? Kartu robot. Padahal ini belum jadi car. Apa gua kebalik ya? Oh ini. Nah yang pertama dia kayak gini dulu, gaya dulu guys. Kayak dulu, kayak gini. Habis tuh.
Bang, ayo siap-siap bang. Turun nih. Kamu
Ya.
Okay, I want to set you a couple of extension tasks that I'm not going to show you how to do. But before you do it, I do need to show you something with the timer, a slightly different way of doing the timer. But if you don't do this, you won't be able to do one of the extension tasks that I set you. So what I'm going to do is this. I'm going to do that. Now, you're probably thinking, well, hold on a moment. If you do that, and we'll leave the stop all in there for the moment, forever, then surely your timer's going to go to like -1, -2, -3. How do you know when it should stop? Well, the answer is that I want to say if timer is equal to 0, then stop. So how do I do that? Well, I'm going to show you this one. If, and I'm going to get something called an operator here. And I'm going to get this equals one. I'm going to drop it in there. And what I'm going to do is do this. I'm going to show you that it works, first of all. I'm going to go to variables. I'm going to grab my timer and put it in there. And then put that there. And then I'm going to put that inside there. Now let's have a quick look at this code first of all, because I've a bit of a big jump here. What this now is doing is when the green flag is clicked, set timer to 10. Forever, wait a second, not one off the timer. If the timer is equal to 0, then stop the game. So in fact, watch the timer. We won't whack a couple of beetles for going it. What will happen? It still will work. When it gets to 0 in a second, the game will stop. And that's great. That's what we want to happen. But the reason for doing it this way is now I can set you a couple of challenges to improve your game. Challenge number 1. We've been whacking beetles, and apparently this is a good thing. Well, it is in our game. In real life, don't whack, just put it out the window and put it in a cup. You know, they're not going to bite you. Well, I don't know. In Australia, they probably would do, would they? Everything bites you in Australia. All right. Yeah, where was I? What was I talking about? Well, maybe we could have cats appearing on the screen. You don't want to whack them. If you whack a cat, maybe your score goes down by 2 or 5 or whatever you decide on. But maybe you could have something that appears that when you hit it, it gives you extra time. Now that's possible if you do it this way. Because, for example, maybe if a dog appears and you whack the dog, timer goes up by 5. Well, that's okay. That would still keep doing. That would work with this particular way of setting up. But if I had that repeat 10 seconds, the game will only ever last 10 seconds before it stops. With this setup, the timer can change depending on animals that you whack. So that's the challenge. Let's go through that again. Number 1, can you put an animal on there that if you whack it, you lose points? And challenge number 2, can you put something on there that if you whack it, it adds a score onto your timer? You probably don't want to have the one that adds score onto your time, adds onto your timer. You don't want to have that appearing very often, I don't think. Maybe it should only be on the screen for a very short period of time. But actually, all the skills that you need to make that happen we have already taught you. So you can make it happen. So that's your extension task. See if you can improve this game. So if certain animals appear, your score goes down. If certain things appear, your timer goes up. Actually, hold on 1 second. I've just had a thought, something that might really, really help you. I mentioned that you probably don't want the thing to increase the timer to appear very often. I want to show you how you can do that using a little technique. So I'm on the beetle now, and we know that if I whack the beetle with the hammer, then the beetle would appear somewhere else, because the command says if you touch the hammer, change the score by 1, hide, go to a random position and then show. But what about if I wanted the beetle to wait a bit before it appeared? So we know that in control we have this command that says wait 1 second. Now if I do this and put it there and press run, I whack the beetle, it waits a whole second before it reappears. Like so. Which is okay, but it means that I'm only ever going to... There we go, I scored 6 in my game. But what about if we wanted it to wait a random amount of time? Well, in fact, actually, there's an operator here that says pick random 1 to 10. And I'm going to put it in there. Now, watch what happens. Got the beetle. Now, it's picking a random number of seconds between 1 and 10, and it looks as though, oh, there we go, about 7 seconds, there we go. So, unfortunately, not a great game, because I've got to wait ages for the beetle to reappear. But the reason for what I can do here is this. This is divide by 1, whereas this one here is divide by. So if I put pick random 1 to 10 in the first bit, and then I say divide by 10, what you will now find, if I put that in there, is this gives me like tenths of a second. So, where's my beetle? Oh no, I've completely forgotten to do something. It's a bit embarrassing. We'll have to go back to the other games. When my beetle was hidden, so I'm going to have to go to looks here. I forgot to show my beetle, down the bottom there, when we start the game. How embarrassing. Right, so there we go. And now, did you see? There's a bit of delay, and sometimes it's quite quick coming back, and sometimes it's quite slow coming back. That was a slow one, I've run out of time. Just to emphasise that again, that was quite a long delay there before the beat, not a long one. That was a quick one there. It was so quick that you didn't actually see it. But sometimes the beetle takes a long time to come back. Sometimes it takes a short time to come back, because it depends on, it's just randomly deciding how long it's going to come back. Now, I probably don't want that on the beetle. I always want the beetle to reappear instantly. But I could use that command on other animals or objects that I want to pop up to change the score negatively or to add stuff onto the timer. So that's something that you might want to consider, is that you can have this random element, and if you want just seconds, pick random 1 to 10, but if you want tenths of a second, you can actually put that in there, and then you get, say, instead of picking, say, 5, it would do 5 divided by 10, which is a half. Or if it picks 7, 7 divided by 10, which is 0.7 of a second. So that's what I would do, and use that command, but use it on 2 other objects to make them sort of randomly appear on the screen at different times. Now that is enough for you to go and to complete those extension tasks. In this video, what we're going to do is we're going to get you to put the animals, the beetle and the hammer, to the appropriate sizes. And we're going to make that hammer do a whacking motion to make it go up and down. So, let's go to work. What do we have to do? Now, I'm not going to do a watch and repeat type video. This isn't going to be how this is going to work. I'm going to give you some clues as to things that you need. I'm going to show you the blocks that you need. Then you're going to put it together. And if it doesn't work, it's not a problem. There's a solution video in a moment. Hopefully, you won't need it. Let's start with the easy bit. Let's go to the beetle. And we want to say, the game starts, by the way, when you press the green flag. So, when we press the green flag, we want that beetle to be much smaller. We want the hammer to be a hell of a lot smaller as well, but the beetle needs to be smaller than it is. So I'm going to do this. Over on the left-hand side, we've got something called events. And in events, the very first one is when green flag is clicked, or in other words, when the game is started. So, I'm going to do the beetle for you. We're going to go to looks. Sorry, I should have said we're going to go to looks now, because we want to change the size of it. We want to change what it looks like. And in looks, we have this 2 blocks here, change size by 10 and set size to 100%. I see a lot of students in the past, they always use change size. We don't want that, we actually want set size. So if I do this, and I press the green flag, nothing's happened, because the beetle is at 100% of its original size, in other words, the same size. If I change that to, if I go into there and delete that, and let's change that to a 50, let's see what happens when we press the green flag. Now the beetle is much smaller. And I'm kind of okay with the size of that beetle. Might want it smaller when I build my real game, I don't know yet. But for the moment that will do. But one thing is for sure, the hammer is absolutely enormous. Absolutely enormous. I don't want that. So, what we're going to need is, again, events. When the green flag is clicked, we need looks, and we're going to have set size too. Now, I'll do this one. Let's make that a 10%. Will that be small enough? Actually, that's not bad. I like that. But I want that hammer to be whacking up and down. And to do that, we've got a little bit of teaching to do, and I'm going to show you some blocks that you need, and I'm going to give you the opportunity to work it out. So that hammer, when we press the green flag, it should be whacking up and down. So how do we do that? Well, we need the following commands. Well, actually, first of all, before we do the following commands, we need to draw another version of this hammer. Let me show you something. Let's go to costumes, where we have this hammer. And what we want is, we want the hammer sort of, this is in its up position, and maybe you want the hammer sort of lying flat, as if you're whacking down on it. But I can't move this hammer. I'm trying to click on it. Oh, and nothing is happening. Because with the graphic that I bring into Scratch, I need to do this. I need to convert it to a vector. I just have to hit this button here. And when I click on it, it looks like nothing has happened. But now, actually, I can actually click on the hammer. And you will notice that I can move the hammer around. Now, I don't want to do that. So I press Ctrl Z there to undo. Let me just do that again for you. If you move something by mistake, you can either hit Ctrl Z on your keyboard, or you can press this button here, which is the undo button. And I do that, and it took it back. But what I want to do is, I need you to look up in this top left-hand corner here. It says costumes, and this is what we call costume number 1. You can see number 1 there, and it says hammer. And what I'm going to do is, I'm going to right-click, and I'm going to duplicate. So now I have 2 costumes. Costume number 1 is called hammer. Costume number 2 is called hammer 2. But hammer 2, I want that to lie flat. But because I've converted it to a vector, and I click on it, I can now, down here, I can rotate it. Oh no, that was a mistake. Let's undo that. What I really want to do is make it lie flat. So now I have hammer, and I have hammer 2, and you can kind of see what's going on here. It looks like it's whacking it down. So I'm kind of happy with that. Well, I'm happy with the positions of the graphics, but I haven't told the computer to keep switching between the costume of hammer and hammer 2. So how do we do that? Well, over here, I'm going to show you the blocks that you need. You can see switch costume to hammer 2. Wow! Look what happens. If I just put that there for a moment, watch my hammer there. Look at that, it's gone down. But I want it to go back up again. So in fact, I'm going to need 2 commands. One to switch the costume to hammer 2, and one to switch the costume to hammer. But then what of course I'm going to need is that I'm going to need to tell it, and this is, sorry, I actually clicked on control actually. There's a command here to wait 1 second. And I can go in here and I can make that 0.1 if I want to. So that's like a real tenth of a second, or if I want half a second, I can make it 0.5. The time that you choose is completely up to you. But what you're also going to need is this command here, a forever loop. Now, what needs to happen is this. You want to say this hammer forever is going to start at costume hammer, then it's going to wait a period of time, and then it's going to switch to hammer 2, and then it's going to wait a period of time, and then it's going to go back to hammer 1 or hammer. So I'm going to get you to work out what you think needs to happen. This is your challenge now. Can you put these blocks of code into this forever loop and then put the forever loop and glue it up there so that when you press that green button, your hammer is whacking up and down? Now, I've missed a block out. See if you can work out how I've missed a block out. Try it and see if you can solve it yourself. And if you can't, there's a solution video for you in a moment. Don't need a new block. I just need 2 of one of those blocks that's there that I've only got 1 of at the moment. See if you can work it out anyway. Off you go. Okay then, one whacking hammer. What do we need to do? So I'm going to put that one in there. I'm then going to put wait 0.5 seconds. I'm going to put that one in there. And if I do this, it's not going to work. Watch what happens. What's going on with the hammer? It's like flashing. Because, whoops, what I needed was 2 of those 0.5. I need to just duplicate that one. Oh, I'm going to pull that one apart and drop that over there. Let's stop the game for a moment. And I needed, this was the extra one. So it basically is going forever. Switch the hammer, wait half a second, switch to hammer 2, wait half a second, switch to the hammer. And it stays in this loop. But now, what I should have is a whacking hammer. I think that hammer is whacking a bit on the slow side. I think maybe I should have run with 0.2. Let's try that instead. And let's run that. Yeah, that's much better speed of hammer whacking. I like that. I'm quite happy with that. I think it's time to move on to our next task. Okay, so we have a pretty good working game now. I can whack beetles all day long. But of course, what we really want to know is, well, how many beetles have I whacked so far? Have you been keeping score? I haven't. I guess it must have been about 1 million. That's how good I am at the game. I've no idea how many but I got, but surely there must be a way of keeping a record. And the answer is yes, of course there is. What we want to do is this. Okay then, let's make this beetle appear and or disappear and appear. So if I'm touching the hammer, I'm going to hide. I'm then going to go to a random position and I'm going to reappear. But the extra block that you needed was a forever loop. So back in Control we have forever, and that needs to be done like that. So let's see what happens. Whack that beetle. Look at that. Look at my beetle whacking skills. Every time I hit it, oh, it's going to a random position somewhere on the screen. Pretty cool, huh? So you'll know if you've got a working game because, well, that will be working for you. Right then, I think it's time to move onwards. Okay then, now I'm pretty happy with my game, but top tip, whenever you're working with Scratch, if you're using the offline version, please make sure that you regularly save your work. Okay? Worst thing that can happen to you is finish this lesson, don't save your work, someone logs you off, and the next week you've got to do it all over again. Anyway, let's go back to the game. At the moment, I've got a whacking hammer, happy with it. It's following the cursor, great. But what should happen is that when I whack the beetle should disappear, and then a new beetle should appear somewhere on the game area. Now, there's a couple of things here. Number one, every time I start this game, that beetle, to stop, is always in the same place. I'd like that beetle to be somewhere else. I also think that beetle's a bit on the big side. So let's have a look at the beetle. I'm going to click on it, and I can see the code, set size to 50%. I'm going to change that to 30, press the game. Yeah, I think that's a better size. Now, how do I make it go to a random position? In fact, we've already done that because we used it in our last one to go to the cursor, to go to the mouse pointer. We used that on the hammer. It's that same block. And now, check it out. The beetle's up there. Stop the game, the beetle's over there. In fact, I'll just keep pressing this green flag and you can see the beetle's jumping all around all over the screen. And that's what I want to happen. When the game starts, I don't know where the beetle's going to be. I'm going to go and whack it. It should appear anywhere. But what should also happen is the following. When I've hit the beetle needs to disappear and then reappear somewhere in the game. So the beetle could be here and then I whack it and then it appears down here and then I whack it and then it appears over here and then I whack it and it appears somewhere else on the screen. And the whole point of this particular game, and the way we're going to keep it quite simple, is we might have a time limit of 30 seconds. You've got to see how many beetles you can whack in 30 seconds and it will keep a score. But we need that beetle to disappear and then reappear somewhere else in the game. So how do we do that? Well, this is your task. I'm going to give you the blocks and you see if you can solve it. So these are the blocks that you're going to need. Number one, you need to say, if the beetle is touched by the hammer, then disappear. So how do we get an if command? Well, if we go to Control, we find something called if then. And I need that block. Now you'll notice this sort of shape here. And in here, we need to put a special block. And we find it in sensing here, the one below. And there's one here that says, if touching, and you'll notice there's a drop-down arrow. If I'm touching the hammer, then I need to disappear. Now to disappear, we need to change the way something looks. And at the moment, it's we can see it. But right down the bottom, you've got to scroll a little bit, so I'll put it up the top now. There's a block to hide. So, we need that one. But then, what we need to happen is this. So if I'm touching the hammer, I must disappear. And then, I must go to a random position. Well, we know that block. It's that one. And then, I must reappear. Well, if I'm going to hide, I then need to, and again, it's right down the bottom, I'll scroll, whoops, up, I need to show. So, What I want you to do is take these blocks of code here, let's put them there, take these blocks of code here and see if you can change the code on the beetle so that if you're touched by the hammer, you're going to disappear, you can go to a random position and then you're going to show again. The problem I have is this. That only does that once. Just like whacking the hammer, I need one more block. I'm going to let you think about what block that is and see if you can put it all together. But you'll know if it's right because you'll whack a beetle and it will pop up somewhere else on the screen. See if you can solve it. Okay then, so we have a hammer, we have a beetle, I press play and the hammer is whacking away. Now I think in the last task video I was waiting 0.5 seconds and I realised that was a bit slow, so I've changed that to wait 0.2 seconds between switching between the costumes and of the hammer, that's looking pretty good I think. I'm quite happy with the whacking speed on that hammer. Now what I want to do is, to make the game work, I want to be able to move that hammer around. And the sensible thing to do is have the hammer follow the cursor. So if I move my cursor on the beetle, the hammer should whack the beetle. How do we get the hammer to follow the cursor? Well, actually, there's a really simple command to use, and it's this one. It says here, go to random position. But if I take that out, and press the arrow, go to mouse pointer. Now I'm deliberately going to do this wrong. So you're probably thinking, okay, no problem, when the green flag is clicked, we can put that in there, and we can put that like that, and we press the green flag, and the hammer's gone up there. And when I move down, it's not following the cursor. The reason for that is, look at this command here. You say to the computer, hammer, go to the mouse pointer. It did. Hammer, make yourself smaller. Well, it did, but it was so quick we didn't see it. And then it says forever. So the whole thing is the only instruction the computer's doing is this set of instructions here. Switch to hammer, wait 0.2 seconds. Switch to costume, hammer 2, wait 0.2 seconds. It's doing that whole whacking thing. And that's all it's doing, because that's all we're telling the computer to do. We haven't told it to go to the mouse pointer again, to keep going to the mouse pointer. The whole point being is we want the hammer to follow the mouse pointer forever. So you might be thinking, oh, in that case, should that one not go inside there? And the answer is, it works, sort of. Now, that's not a lag on your screen, it's jerky because it's taking a bit of time to follow the hammer. I'll just move it around in a circle, like so, and you can see it's quite laggy. And the reason for that is that, look at the commands. Go to mouse pointer, and then it's got to go through switching to costume hammer, waiting a bit of a second, switching to costume hammer 2, waiting a bit of a second, and then it will go to the mouse pointer. Now, if I do this as 1 second and 1 second, it sort of will emphasise this a bit more. Watch the delay now. I'm following, look at my cursor, and look, the hammer is taking a long time to follow the cursor because it's only doing it every sort of 2 seconds, because basically the command is hammer, go to the mouse pointer, switch to costume hammer, wait 1 second, switch to costume hammer 2, wait another second, and then go to the mouse pointer. So it's 2 seconds between every time it goes to the mouse pointer. So this, whoops, doesn't go in there. You can use that block more than once. You can have 2 different sets of scripts. So here's your little challenge now. Hopefully it's quite simple. When the green flag is clicked, we want the hammer whacking on one block here, And when the green flag is clicked, the hammer must follow that mouse pointer forever. See if you can solve it. Right, we're beginning to get somewhere with a game, and you can see where this is going. At the end of the day, I can whack beetles, and you can see how many have I whacked so far. I don't know, I've lost count. Turns out I've whacked 10 beetles so far. But not much of a game, because I'm up to 16, and quite frankly, this could be a very long video if I carried on. So how can we turn this into a meaningful game? Well, I think the only way we could do this at the moment is maybe we could have a timer set at 10 seconds. And when the game starts, you've got to whack as many as you can, and then the game will stop after 10 seconds. That's all there is to it. And you can see how many beetles you've whacked. That would work as a game. You could challenge your friends. So here's the thing. How do we do that? Now, to do it, we need to make a timer. And making a timer, you'd thought Scratch actually would have come up with a nice simple thing, but they kind of haven't. You have to manually make it yourself. But it's really not very difficult at all. So what I'm going to do is I'm going to head back to variables, where we made our score variable here. I'm going to make a new variable that I'm going to call timer. And I'm going to press OK. Now, the way this works is when the game starts, timer set to 0, knock off one, timer set to 10, my apologies, then every second knock one off until it reaches 0 when you stop the game. And that's going to be your task. But here's the thing. I want to show you a new place that you can put code. Because the timer isn't really about the beetle or the hammer, it's about the game itself. So it's not a great idea to drop the code for a timer on the beetle or on the hammer. So you're probably thinking, well, if it's not going on the beetle and it's not going on the hammer, where else can code go? And the answer is, there are in fact, let's move that out of the way for a moment, there are 3 things in this game: beetle, hammer, and the stage or the backdrop. Now, over here on the right hand side you can see it says stage and it says backdrops here, funny enough. And if I click on it, you'll notice that the code stuff can be dropped onto here, onto the backdrop. That's what we're going to do in a moment. Just so you know, if you wanted to change that white background, all you've got to do is press this button down here, and the easiest way to is choose a backdrop, and you can choose one from the library, like Blue Sky. So we've got hammers and flying beetles. Well, it works. Of course, you still have the option to paint your own backgrounds or get a surprise one or upload a backdrop. And if you're not happy with the backdrop that you've got, you can just click up here for backdrops and you can bin the one that you don't want. So we'll go back to a plain white background. But we can go back here and put code. And this is what the challenge that I'm going to give you now. I'm going to give you the blocks and see if you can get it to work. So we're going to put some code on the stage. And the blocks we're going to need is events, when the game starts. So when the game starts, we're going to need to set one of our variables to being 10. And then we're going to need to wait 1 second. And then we would need to change the variable by -1. Back to variables, change the variable by -1. So 10 becomes 9, becomes 8, becomes 7, becomes 6. Now, here's a bit of maths for you. In control, we have this block that says repeat, and it says 10 times. And also, we have this one that says stop all. Just using those blocks and using a bit of common sense on your part, can you make it so that when the timer reaches 0, the game stops? See if you can solve it. Okay then, let's show you what to do. So, when the game starts, I'm going to set the timer to being 10. I'm going to repeat 10 times. The weight needs to go before that. Okay, and then I'm going to change my timer by -1. And then when that's done 10 times, I'm going to stop all. Now let's watch the timer. Let's put it up in the top left. Let's play the game and watch the timer to see if that works. Okay, we have to wait, talk amongst ourselves, like a whack a beetle whilst they're doing it. Whack a few beetles. Let's see what happens. 3 or the timer 1. And look at that. The game stops. The timer hits 0. The game stops, and I'd whacked 7 beetles. That's not my record. Obviously, I could probably get millions. Probably get millions with my cat-like reactions. I don't know what my score will be, but I'm not going to make you suffer and watch that. So that's all that you had to do to get your game working. Now we have a working game. I mean, you could challenge your friends to whack as many beetles as possible, and you could compare your scores. Hello there. Now, in this series of videos, we're going to teach you how to make a very simple yet classic Scratch game. And that's what we know as the Mole Smash or Mole Mash, you might know it as. And you may have seen this game in sort of arcades or fun fairs. The physical game looks a bit like this. But there are also digital versions of that game that look sort of like this. And that's what we're going to do. We're going to make something that looks like a digital version in Scratch. So we're going to keep it simple, and in this video you'll watch it through, and at the end of it I want you to create 2 graphics for me. A hammer or a mallet, whatever you want to call it, we're going to whack with, and also the object that we're going to be whacking. Now, Scratch by default looks a bit like this, and you can see that this little square up here, or rectangle shape, not square, is of course the game area. This is where the game is going to run. At the moment, by default, it puts the Scratch cat in there. And I don't want a cat there because we're not going to whack cats because that makes some people get quite upset. Beetles, fine, we can smash them. Cockroaches, yeah, smash them. But cats, people get upset about that. So, although Tom and Jerry have done it for years, so why people get upset, I don't know. Or did I think maybe just getting upset, something I've made up. Anyway, it doesn't really matter. I don't want a cat. So, how do I get rid of the cat? Well, down here, there's a little mini version of the cat, and I can press that bin there, and it's gone. So we want 2 graphics still. And how do we get those graphics? Well, down here, little cat head as well, look. It says choose a sprite. And I've got 4 options. I can upload a sprite, which we will come back to. I can get a surprise sprite, which if I click on it, gives me a snowman. It was a surprise. I wasn't expecting a snowman. And the whole point being is that you click on surprise. Oh look, I've got a what? A takeout? Surely that's a bucket. I don't know who named that one. Takeout is what you get from a Chinese restaurant or something like that, isn't it? Oh, maybe that's what it is. Whew, I'm not convinced. I think it still looks like a bucket. Anyway, that surprised me. Or I can paint a graphic. Now, if you want, you can paint a hammer. And it's quite easy to do. What you do is you take a rectangle and you choose your fill colour. I'm going to go with black to start with, and I'm going to draw a rectangle, and look, there it is. That's like the handle of the hammer. And then I'm going to draw another rectangle. I'm going to go with, I want some sort of brown colour, I think. Oh no, look, I've changed the colour of that one. Oh, you know what, let's have a brown handle, doesn't matter. I'm going to draw another rectangle, like so. It's a brown and a brown one. Let's change that one to black then. That would work, wouldn't it? So I've got a black Ah, there we go, I've got these anyway. And what I'm going to do now is I'm going to take that off. Oh, I need to choose this one here, and I can put those together like that. Lovely. And what I can do is I can select both of them like so, and then I can group them together. And now look, I don't move the rectangles round independently. So I can draw a hammer if I want to, but it's really important. Here's a really important bit. If you do decide to draw something, watch this. I'm going to zoom in. See that blue cross? That's the middle of the hammer. Do you notice that target has appeared there? Like a sniper rifle. Well, that's the middle of the sort of, I don't know what to call it, the canvas for the hammer? I don't know, but all I do know, and this causes 99% of the problems I get from my own students, is the fact that they haven't done the following. If you draw anything, you must make sure that blue cross and that sniper rifle sight are lined up together. So, you can draw a hammer like that if you wanted to. That's one way of doing it. Now, let me show you another way that we can do this. We could look in Choose a Sprite. We look in a library. We've got beetles that would be good for smashing. I think I'll drop a beetle in there. Yeah, I'll leave that one there. But were there any hammers there? Let's have a look. So, let's go down. It's alphabetical. Ah, here we are, H's. I've got a Hannah. Not a hammer. Hair. Oh, that's it then. There's no ham. So there's no hammers. Maybe mallet. Let's have a quick look a little bit further down. Microphones and magic wands. Oh, I could do a magic wand going up and down. No, we haven't got a hammer, we haven't got a mallet, so we're kind of out of luck in the library here. But you can have a look through for stuff that you might want to use in any games that you build. But if you're out of luck and you're not very good at drawing rectangles, which is a bit of a stretch because everyone can draw a rectangle, but let's say no, you're saying this is not professional, I want professional, proper hammers. What you can do is this. If you head to Google, or any search engine of your choice, what I've done is I've typed in clip art hammer. Now, this is really important. I'm going to go to Tools here, and I'm going to choose, where it says Colour, I'm going to choose Transparent. But really importantly, because we want to teach you right from wrong here, kids, where it says usage rights, you must change that to Creative Commons licenses. Now, I'm not going to explain what that means, but what I am going to tell you is this. I'm allowed to use all of these images, and it's not like a breach of copyright. No one's going to come and arrest you. Well, they're not going to arrest you anyway for stealing a picture. Well, not arrest you, but you can get fined when you're much older. They wouldn't fine you as children. But anyway, it's just good practice to make sure that any images that you use are actually Creative Commons, so therefore you're not going to upset anybody. Now, I like this one. Look at that hammer. That's a beauty. So I'm going to right click on it and I'm going to choose Save Image As. Now I've already set a folder up called Mole Smasher Game, and I have already done this before because at the moment it says image processing 202022. Okay, let's just call it hammer, which I'd already done because I've saved this already. So I'm going to press cancel because I've done it, but you would need to press save. And then back in Scratch, what we have to do is this. Upload a sprite. And it says, what do you want to upload? I'm going to choose hammer. And there is my fantastic hammer that's far too large. It's far too large. But we're not concerned about that. The size of it doesn't actually matter. So that's your task. I'll put this one over off the edge for the moment. All I want you to do is to create just two graphics for me. I'm going to leave that giant hammer. I'm going to get rid of this one here. It says sprite one. I'm going to bin that one. I like my hammer. I like my beetle. I think that's going to make a good smashing game. I don't like the size of them, but that doesn't matter. All I want you to do is now to fire up Scratch and to make me a hammer and a beetle. But really, 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 really importantly, when you've done that, because I'm not using the web-based version, I'm using the offline version. So if you're using the offline version, you must do File, save to your computer, I made a folder called Mole Smasher Game. So I'm going to call this Beetle Smash. I wasn't sure, I should have got a mole really, but there we go, we ended up with a beetle instead. It doesn't really matter. But one thing I do know is that my Scratch game is saved in my Mole Smasher Game folder, so I can find it in the future. Anyway, I'm going to save it. That's all there is from me. You can stop this rather long video, but go and get yourself 2 graphics. You can draw them, you can get them from the internet. I don't mind how you do it, but get me a hammer and an animal that you're ready for doing some whacking on. Now I suspect there's probably quite a lot of you watching this video because you can't get yours to work quite correctly, which is fine. I'm expecting that to happen, but I want to explain why. Now, most of you probably would have just grabbed the video motion on Sprite, put that in there, whoops, and then probably on the basis of the video you thought, well, okay, when video motion equals 10 there, it means that make that 10 there. And this works, kind of. I'm going to take that now and drop that into there. And then you'll find, look at that ball. Look at it going. And it's only going up and down because my mouth is moving. I'm not even touching it with my hand. It's it's like super sensitive. I'm almost surprised that if I don't say anything. I'm not doing anything and it's moving. And you'll go, what's going on? Weirdly, if we stop the game for a moment, the default position of the video motion is greater than 50. This works a little better. Watch. Now I can talk and the ball doesn't move, but if I catch it with my hand, there it goes. Woo! Now I've got to really flick that to get it up. There we go. But if I put my hand over here, it doesn't do anything at all. Whereas if I do it down here, I'm not going to lie to you, it is a bit tricky. It does sort of work, but it's not perfect. This is not a Xbox Connect or anything like that. But the solution to this particular video was that you needed to increase that number. So I'm going to just put my let's go back to stage a moment. Let's set video transfer back to 100, so I can disappear off there we go, back to where we go. And let's go back to the ball itself. The key to this one is that it's all about changing that number 10 to a number 50, or using, it's experimenting with the numbers. And interesting enough, you can actually see that I can probably still control the ball. I'm waving my hands to a camera and you can't see me, but I'm still controlling the ball by actually waving my hands. Weird, isn't it? It's still doing it as well. Weird. Anyway, it's not perfect. As I said, otherwise we'd be looking at sort of Xbox Connects and stuff like that. But you needed to change that number. So if you don't have a working game, then experiment with those numbers in there, but it's not as low as 10. Okay then, now we have a game where a ball drops and we can flick it with our hand. Oh, it's running again, didn't mean to do that. We can flick it with our hand and then the ball will go up. Now, here's the thing. I think what we're going to do with this game is that maybe, if your job was to have one ball dropping from the top of the screen and all you've got to do is keep tapping it to flick it up, it would be quite an easy game. I think maybe we could have 3 balls dropping from the top of the screen. So you've got to try and be everywhere at once. So how do we do that? Now, the temptation is to simply copy the ball 3 times, but that's not an efficient way of doing things. What I want you to do is the following. We are going to break this apart. And what we're going to do is that I'm just going to zoom out a little bit. I'm going to pop that bit of code just there for a moment and leave that like that to a bit more space. Now, what we're going to have is this. If I run that now, nothing happens because when the green flag is clicked, nothing happens. This code doesn't run because it's been pulled apart. But what I actually want to do is say when the green flag is clicked, I want to make 3 clones of this ball. Okay, and then the clones will do this. So, when the green flag is clicked, we're going to go to control. Even I should go to is that down here in control, we've got this one that says create clone of myself. But I want to do that 3 times, so I'm going to need this block. Now, that's no problem because then I've got this option here. If I bring it up a bit, when I start as clone, I can then say do all of this. So if we think about this logically, what should now happen is that when the game starts, if I were to put this in, I'm not going to because this is your job to solve something here in a moment. But the whole point being is when the game starts, the ball should make 3 clones of itself, and then that original ball should disappear. So we only see the 3 clones. So what this means is this. You're going to need to use these blocks here. That's why I went to looks, my apologies. But in the looks here, you'll find these 2 blocks here, show and hide. And we've got 2 bits of code here. This bit of a code is going to be applied to the original ball, and this code here, we'll just glue that together actually, to be honest with you. This is what applies to the clones. So your job is to, using a bit of common sense now, when the game starts, make sure we show the ball, then we create 3 clones of the ball, and then we make the ball, the original ball, disappear. So only the 3 clones are left showing, all right? Now you should do that, and you should find that you have 3 balls appear on the screen. If you know, you've got it right, because if you start the game and you set the video transparency back to 0, you should see yourself 3 balls as you were dropping from the screen, and you had to whack them all with your hands. So that's your task. See if you can make it happen. So this is probably the quickest video I'm ever going to do. It was nothing more than, if you made the mistake and did that like that, then what happens here is it won't follow your mouse pointer forever, because all we needed was, there he is, a forever loop. Put him in there, and now, look at that. Oh, I forgot my timings. Put that back to 0.2, otherwise it's looking a bit wonky. So let's put that back to 0.2. Maybe it's not going to be the shortest video ever after all. But now, what we should find is my hammer is whacking away, and it's following the mouse cursor all around the screen, and there's no real lag on it whatsoever at all. So we now need to make it do something with that beetle when it whacks it. That's for our next video. Okay then, so how do we get those 3 balls? Now, the first thing I'm going to do is I'm just going to zoom back in here, just for a moment to make sure that's a little bit easier. I know you can't see all of it, but that's okay. We can scroll to the left and to the right. But what I'm going to do is this. When the green flag is clicked, what we're going to do is we're going to show the original ball. We're going to repeat 3 times, create clone of myself. Pull that out a little bit that way, and then we're going to hide. Now, to show you this works, you should find, well, I've got 3 there, a little bit difficult to see. I've got 3, and they're all on, 2 on top of it. There we go. 3 separate balls have appeared at the bottom, appeared at the top of the screen, but they've ended at the bottom of the screen. And the question is, do they move? And the answer is, well, they like making them move. And you're thinking, how is this by magic? How is he doing this? Well, of course, my web camera is still working, it's just the transparency is set to 100%. If I go back to the stage, I can get my video transparency, set that to 0. And of course, I press then I'm back in the game, and look, now I can interact with all 3 balls in the game. And if I do this over, if I do this over here, nothing happens. And actually, they get the bottom one, so I'll try. I can't do this. I'm just flapping my hands, it doesn't really matter. The whole point being is that you should find, funnily enough, what I found in the past when making these games is actually when you get the clones in, fun enough, the game sort of works a bit better if it's just, well, I don't know how that ball moved there. The game works a little bit better than when you just have the one graphic. I guess maybe, there we go, I can move that with my elbow. So there we go, you should have 3 balls now in your game, and I think we now need to have some sort of scoring system up next. Okay then, now what I want to get you guys to do in this video is to create a simple scoring system. It will get more complex, don't worry, but for the moment what we're going to do is just record a score of getting 1 point if you manage to hit a ball and it goes up in the air. But before we do that, I just want to emphasise a couple of things. Number 1, this code here of when green flag is clicked, set video transparency to 100, this is not on the ball. It's over here. It actually lives on the stage or the backdrop. I will use those 2 words interchangeably. But if I click on ball, I see the code for the ball. If I click on stage, I see the code for the stage. But there are 2 different places in my game that I can drop some code. Now, if we want a scoring system, we over on the left hand side here need to click on this one that says variables, and at the top here I'm able to make a variable which I will then call score. We're not going to worry about this for all sprites for this sprite only, just leave that alone. We'll just make sure it's left as for all sprites, and we're going to press OK. Now you will notice the only thing that's happened is score has appeared here, but also it's appeared on the game itself, and the score is currently 0. So here's my challenge for you. There are 2 things that I need you to do, and one of those pieces of code is going to go onto the backdrop or the stage, and one of those pieces of code is going to go onto the ball itself. So the piece of code that I want you to put onto the backdrop is that when the game starts, I want you to set the score to 0. I know it already is 0, but if I right click and make that a large readout, it stays at 0. But if I right click and make it a slider and do that and put it up to 62, I right click and I go to large readout, it stays at 62. For the normal readout, the score is 62. So maybe I got 62 points in my last game. But the whole point being, if it's someone else's go next, then the score needs to be at 0. So using just these blocks over here, I want you to set your game up so when you press the green flag, the score is 0. And every time you hit a ball, the score goes up by 1. I'm not going to show you how to do it. Everything you need is here. You just need to think about what blocks you need and where they need to go. One of them's going in this bit. One of them's going in this bit. You work it out. I want to leave you with some ideas about how you could improve this game. Now, the logical first one is to have a timer. Otherwise the game goes on forever. Now you're probably thinking, well, how do I do a timer? Now I'm not going to make the video for that because I don't know whether you'll be using the app here or maybe you've got this, your teachers have bought it for your school, however you've got these videos. You'll know there's another game build called Mole Mash or Mole Smash or something like that. And in there is a video that shows you how to make a timer. So you might just go and watch that one, find the video and do that, and you can apply what you learn in there to this game. It's absolutely no different, and I can save a bit of memory and the size of the app by not doing the same video twice. You could, for example, maybe as having objects that drop from the top of the screen to the balls, maybe even another object that it drops from the top of the screen and you don't want to hit it. So for example, if we go back to the stage here, you could set score to 0, but maybe you could set live to be 10 or something like that. And back on where you make another object, but where the ball was, if video motion is greater than 50, then you get a point and the ball bounces up. On the other one, if video motion is greater than 50, then maybe you would lose a life. Or maybe you'll whack it really hard to lose a life. Maybe if video motion is greater than 80, you would lose the life. I don't know. There's no right, there's no wrong. I mean, for example, here, other things you could do. You've got repeat 10, change Y by 10. So it goes up 100. Well, maybe you want to have a random element in there. So instead of changing Y by 10, maybe it can be a random number between, I don't know, 1 and 10, or, whatever you want to choose as your upper and lower boundaries, I think is the right word I'm looking for. Maybe, I don't know, if video motion on sprite is greater than 20 and less than 50, then it goes up by less. Maybe it'd be a smaller number. There are lots of different options that you could do. I haven't even introduced the concept of sounds. And to be honest with you, I play a pop sound, start sound pop. There's lots of different sounds in there. You can record your own sounds as well. But the whole point being is maybe we can introduce some sounds. So if I hit a ball, it does, plays a bit of sound. You'll notice that the ball itself, if I go to costumes here, if you remember the very first video, I think it was the first video, the ball actually was multicoloured. So maybe in your code, you could do some work with, maybe if we hit a ball, it changes colour. It's not a difficult one. In looks, you can use the option to switch a costume. And again, if you go back to the Mole Masher video, I think it's the first one where I do whacking a hammer, then that's exactly the same principle. If you watch that video, you'll learn how to change the costumes on the ball so it's a different colour if you hit it, or maybe the balls will flash and there'll always be colours, different colours they move down. You can work it out. It's not difficult. I don't need to do videos for that. Go and watch the other ones. You can improve your game. There's lots and lots that you can do. If you want to do a bit of Googling, my favourite one, and from a long time ago on the very first PlayStation, they had a little accessory called an EyeToy, which is basically a web camera. And there was a game called Wishy Washy, where there were lots of bubbles that would appear on the screen. You'd have to rub your hand, or you'd have to wave your hands madly, and the bubbles would disappear from the screen. But the principle of that game is no different to the principle of this ball game. It'd be quite an easy build. You wouldn't need to learn anything more to make it happen. So maybe if you want to do a bit of Googling and see if you can find a video of someone playing Wishy Washy, you'll see them doing it and you'll be like going, oh my God, I can make that with the limited code that I already know in the webcam. It's not difficult. So there we go. I'm going to leave it with you now. See if you can improve this game and see how much further forward you can take what we've learnt so far. Right then, that was a pretty simple one to do, but if you'd struggled, here's the solution for you. I wanted the one to set size to. I'm going to take that down to, I don't know, about 40%, I think. Pick random, needs to go in there, but those two numbers need to change from -220 all the way to +220. And the Y, I think I'm going to run with 170. And when I glue that together, like so, and press play, we have a ball. But if I press the play a few times, look at that, it randomly appears somewhere at the top of the screen, and I'm pretty happy with that. So let's move on. Right then. Now, the whole point of this game is going to be that the ball is going to fall down the screen, and then if I hit it with my hand, it's going to bounce up the screen, and we're going to count how many times I can do that in a certain time period, or something like that. Who knows where this game is going to go? There's lots of different options for you. But the thing that I need to do is make the ball drop down the screen. So how do I do that? Well, let's consider the ball being right on this, actually let's put it right next to the axis. The whole point being is that the ball should fall straight down. Okay? So if the ball is here, when it goes through the axis here on the x-axis, it's at roughly, actually let's do it on this side, it'd be a little bit easier to understand. You can see here that x is 100. So if the ball is up here, x is 100, and as it falls down, the value of x never changes. It's always at 100. It falls straight down. The value that's changing is the y value. Here, the x value is 100. The y is about 170. Here, the x value is 100. The y value is 115, 120. Here, right in the middle, the x value is 100. The y value is 50. So when the ball drops, the y value changes. Now, to show you how this works, let me just do this. Let's drop the ball there. And I'm going to do this one in motion over here. I'm going to choose this option that says change y by, I'm going to make it 10. I'm going to make it 50. So if I press, I'm going to undo this actually just for a moment and leave that like that to prove a point. If I press the green flag, can you make a prediction of what's going to happen to that ball? Okay, I'm going to press it and let's see if you're right. The ball jumped up. In fact, what's happening here, if I put that right on the axis and I press the play button, the ball's jumped up by 50. The whole point is the ball has gone upwards. Now, if I make that a very small change, for example, say 4, and I press the green flag, look, it jumped up a little bit. And if I keep pressing the green flag, it's going to keep jumping up. And in fact, it's a bit annoying, let's take it all the way to the top. When it gets to the top, it doesn't actually ever go off the screen. Okay? But it won't go up any further when it reaches the top of that screen. But clearly that's not much of a game if we have to do that and keep pressing the green flag. What we want to do is tell the computer, look, just keep changing the y value. Don't stop doing it. Keep doing it forever. So, my task for you, and this actually is a little bit cheeky, you need to think this through, is I want you now to take those blocks of code, make the ball start at the top of the screen, and then it's going to fall. Okay, it's going to fall. Now, we know that changing the y by 4 made it go upwards. But I don't want the ball to go upwards. I want it to fall. I want it to keep falling. Okay? So your job is to take those blocks. You're going to need to change something in here. Obviously, 4 plus 4 doesn't work, does it? But see if you can do it now so that when you press the green flag, your ball will move from the top of the screen all the way to the bottom of the screen. Off you go. Okay, solution time. Here we go. I'm going to drop this back in here and I am going to get an operator from here. This is the greater than sign. And I'm going to, the wrong one for a start, I want the less than sign. And what we're after is if in motion, you would have found the Y position, this block here, I put that in there. If the Y position is less than minus 170, that needs to go in there. We need to go to a random position at the top, but also in variables, we need to change the score by -5. Right, let's just move this up a bit. Oh, it doesn't go much further. But let's run the game. In fact, I'm going to have to just put myself back in the game for a second to prove a point. Let's run the game. I'm missing the ball. There we go. Oh, that's weird. The score hasn't dropped. Did I not do anything on the ball? Change my variable. Oh, there we go. We all make mistakes. Now what we should find is, look, watch these three, but what's the score? She goes to -15. Look at -15. I'm going to interact with it, but look at that. Oh, we're hitting the balls. It's so easy for me. I'm so skilled. Look at my score. Look at my score. Look at my score going. Look at that. Look at that. Oh no. But look, do you see that? Balls are appearing from everywhere. Actually, this game would be quite easy. Maybe I need more than 3. I can look at that. My score is terrible now. Look at it just disappearing down. I'm going to stop the game. I'm going to put the transparency back to 100 to make life a little bit easier for you. There we go. So that was a solution to that one. You now have a scoring system that if you miss a ball, it goes back to the top of the screen and you lose 5 points. Okay, now I'm going to leave you with a bit of a tricky task to do. I think this is the hardest thing I've asked you to do. But, you know, we're upping your ante a bit here, up in your game. So let's see if you can solve this one. Now, the problem that I have at the moment is that if the 3 balls get to the bottom of the screen, they just stick there. And to be honest with you, the whole point of this game is you get a point for keeping the ball up, but maybe when the ball gets to the bottom of the screen, you should lose some points and then the ball goes back to the top of the screen and drops from the top again. So I think that kind of works as a game. But how do we do that? Now, here's the thing. I'm just going to take the hideaway for a moment and leave that there. So now we can actually see the original ball and the 3 clones. But the reason for doing this, I actually want to use the original ball here. Now, when the original ball gets down to the bottom of the screen, we know that its Y value is going to be, well, we don't know if it'd be exactly -180. But as the ball is only moving in steps of 4, we do know that when it gets to the bottom of the screen, its Y value must be, well, I won't get too complex, but it's going to, oh, let me stop the game for a second because these 3 balls can keep moving as I keep moving my head and hands in front of a video camera that you can't see. Does that make sense? Maybe not. Anyway, look, let's focus on this ball. We know that the Y position of this ball is going to be certainly less than -170. I mean, -170 would be around about there. So when the ball gets to the right down the bottom, we know that it's going to be less than -170. So what we really want to do is say to the ball, look, or say to the clones of the ball, which is in here, of course, we know that if you sense a video motion, then go up and change your score. But if your Y position is less than 170, then take 5 off the score and go back to the top. So my little tip that I'm going to give, you'll break this apart and break that apart, is I'm going to duplicate that and put that down there. Then I'm going to put this back together again. So inside this if, we have, well, so not inside this if, inside the forever, the ball is either going to be dropping by 4, or if something moves on it, then it's going to go up by 100 and change the score by 1. But now we want a second if inside this forever loop. The if mustn't go inside the other if, as it's going to go in, oh, do you know what, it might be easier if I just do this one, just a little tip for you so you get it right. We want another if, an if that says if the Y position is less than 170, then change the score by, I don't know, -5, and then go back to the beginning and start to drop again. That's your task. That's all I'm going to give you. And you're probably thinking, well, how do I do the Y position of the... Well, why don't you have a dig around in some of the blocks? I would perhaps start with the motion blocks and see if there's anything in there when you scroll. Because all you've got to do is scroll through them using this bar here. Is there anything in there about the Y position? Well, there is. You just need to go and find it. Okay, solution for this one was as simple as this. I'm going to head to the stage, and when the game starts, set the video transparency. We'll set it back to 0 in a moment. I know you're excited about seeing me again, but I'm going to set score to 0. And if I go back to the ball, where if my video motion on sprite is 50, then do that. But I'm also going to change, I'll put it in here, the score by 1. Now that can live there. It can live, oh dear, okay, it can, let's do that again. That can live at the bottom. But where it can't live, if I pull that out, is in there. If I did that, then it would actually increase my score by 10 and not by 1. So if your score is going up by too much, it's probably because you put that one in the wrong place. It either comes after the repeat 10 or before the repeat 10, but not in the repeat 10. And to prove to you it works, let's go back here. Let's set the video transparency to 100, to 0, so you can see me again. And I will whack a few balls. There we go. I don't know what I'm doing, but the whole point being is that look at that scoring. Look at the score up in the top left. That I got 14, some sort of world record, I'm sure. So there we go. That's it for this particular one. Oh, I've got 15 now. I moved my hand. Look, there we go. 17, 19. Oh, honestly, no one's going to ever beat that score. But that's it for the moment. I think it's time to move on to our next task. Right then, now, the whole point of this game is going to be the ball drops from the top. If I whack it with my hand when I switch the video back on, the ball will bounce up again. It's like a keepy-uppy type game. So I want to show you how to do this. Well, no, I don't want to set you a little task to do, but I want to show you a slight problem first of all, which is going to help you with the solution. Just trust me, all right? Now, what I'm going to do is this. I'm going to grab over here from the control block something called an if block. And what I'm going to do is I'm going to grab this one. This is completely the wrong one, by the way, but it's got if key space is pressed. And here you can choose any of the keys on your keyboard. I'm going to stay with the space key. And what I'm going to do is I'm going to say that if that's pressed, if I press the space key, the ball is going to go up. Back up the screen. So what I would do, just using the same block here in motion there, which is the old change Y by, we did X for a moment there, I'm going to make that 100. Now this is wrong. Well, it's going to work, sort of, but watch what happens. I'm going to put that into here. So now what's going to happen is my ball will go to the top of the screen, reduce its size, and it will start to fall. But if I press the space key, it will jump up by 100. And let me show you that happening. Space. There we go. Space. Now, you'll also notice that I've got to kind of tap it to make it do 100. If I hold it down, it just jumps straight to the top. But there we go. The whole point being is this. It was a big jump. Here's a slightly smoother way of doing it. Instead of changing Y by 100, I'm going to change Y by 10, but in control, I'm going to repeat that 10 times. Now, if I put that in there, and I'm going to try and, let's try that, I don't want the ball over there. I'll tell you what, actually, let's just do that. I'm going to tap the space key from the bottom. Watch the ball. You see how the motion of it going up was sort of smoother than previously? Rather than jumping up 100 places, it's actually jumping 10 at a time, and the motion of it is a little bit easier on the eye. So, let's stop that for a moment. Now, my problem is, I don't want this to happen when the space key is pressed. Now, what I need to do is, on the stage at the moment, whoops, no, actually what I'm talking about, I need to bring the old video transparency back in. So I'm going to set the transparency back to 0, and let's run that there. So I'm back in the game. There we go, there's me again. Now the whole point being is that if I do this with my hand, if I do this with my hand on the ball should go up. Okay? That's the point of the game. The whole point, the ball should be dropping from over the screen, and if I go, ooh, if I hit the ball with my hand or flick it up like that, the ball should go back up the screen. So, we're going to lose that here. Now, how can we sense motion on the video camera here? How can we sense my hand is moving? Well, the answer is, in video sensing, we have this option here. Video motion on sprite. It says on sprite. Video motion on sprite. Well, that's interesting. I thought it would have given the option for ball there, but I suppose it doesn't make any difference really. I want to say if the video motion on the sprite is bigger than, well, I don't know. Look, up here it says when video motion is greater than 10. That would do something. So, I'm going to need this greater than option. By default that says 50. So this is your task now, is that I want you to set this up. So when you put everything back together, and it's quite a simple exercise really, you just put that in there, put that in there. But is 50 the right number? I need you to experiment with numbers so that if I wave my hand, or flick my hand like that, the ball goes back up the screen. But do I need to do it a lot? I mean, how much video motion is there? Or will a gentle like that do the job? I don't know. I don't know, is that going to be fast enough to do that? Or is it got to be pew? So I've got to pew, pew, pew. There's lots of balls on the screen. I'm going to flick my hands all over the place. I don't know. Why don't you experiment and see what happens? And if you can't get it to work, there's a solution video coming up in a second as well. Okay then, a lovely simple solution. All we had to do was do the random bit at the top again, so we can see that's working. And then the change by 4 goes in here. I'll put that there. But of course, if I do that, the ball is stuck to the top because it's trying to go upwards. If I press stop, if I change by -4, then we will find that the ball, in fact, will fall down the screen until it hits the bottom. It's still trying to go down even further, but it's on the edge now, so it won't do that. So that's all there was. It was just a question of making that a negative number rather than a positive number, and every time that you start your game now, the ball will actually fall from a random position at the top of the screen. Now we need to try and make it bounce up again. That's going to be our next task. Okay then, one solution. So here we go. Glue that back, glue that back. In here, I want the greater than operator. I'm going to pop that in there. I'm going to go to motion, and I'm going to go and grab, if I scroll up a bit, the X position. I'm going to put that in there. We said if it was greater than 230, if that is true, then go to there. Now that if block needs to be glued inside here. So let's think about this. It says, set my size to this, pick a random position, move by 3, but if you're bigger than 230, then go back to the beginning and start again. And you know what? Watch that fish. I should have maybe changed it from 3 to something a bit bigger, shouldn't I? Look at that. And there he goes. And he's randomly appearing on the left-hand side. And we have our first fish going from left to right that the shark must catch. And I caught it and nothing happened. Because we haven't said for anything to happen when the shark catches the fish. I think that might just be our next task. Hello again. Now, in this series of videos, we're going to show you how to make a simple webcam game. And when you've learnt the simple components of it, you can go on and build something a little bit more extravagant than what I'm going to teach you. But this is going to involve a webcam. And the first thing that we need to do is to show you how you can fire your webcam up. Now, the blocks that we have over here don't include anything to do with the webcam, because the webcam block is actually an extension block. In the old Scratch 2 it was actually built in already, but in this version we have to click on this button down here, and we've got this one here that says video sensing. So I'm going to click on that, and you'll notice that I have appeared in the background over there. Now, there's a couple of things that are a problem here. Number one, cat's obscuring my beautiful face. And number two, it's a bit blurry, isn't it? So, first of all, we can get rid of the cat by hitting this little bin here. And look, there I am. I know you're thinking, goodness me, who is that? That looks a bit like Jason Statham, doesn't it? No, I'm afraid I'm not. But anyway, if you want to see me a bit more clearly, actually there's a simple way that we can do this. Over here on our buttons, if I click on the one that says Events, we have this button at the top that says when green flag is clicked. Now, the green flag is basically here, and when you want to start your game in Scratch, that's what you press. So I'm going to grab that one, and then I'm going to grab this one called Video Sensing over here. And you'll notice there's not very many options here, but one of them is set video transparency to 50. Now 50 is the default, and this is a percentage like 0 to 100. So I've always been a little bit surprised that Scratch puts the default as 50, which makes it a little bit on the blurry side. Now look what happens if I change video transparency to 0 and press the green flag. There I am in Technicolor beauty. Now some of you might be thinking, he's not really Jason Statham, nor does he actually look like Jason Statham. You'd be wrong, of course. I look very much like, I don't look anything like Jason Statham. It's just, we have similar hair because I'm very old and going bald. But let's get rid of me for a moment by setting that to 100, and we'll press play, and I've gone. So there we go. If you want to see the camera in its full glory, set the transparency to 0. And if you don't want to see whoever's in the background, set it to 100. I'm going to leave it at 100 for a moment because it is now time to set you a task to do. And that task is that I want you to introduce an object here that's going to appear randomly at the top of the screen. So the whole point of the game being is that I'm going to use my hands on the webcam to interact with the object that's going to drop. So the easiest one of all is to have like a football or a baseball or whatever it's going to be, and as it drops you flick it and it goes back up the screen. You can maybe count how many times that you flick the baseball up and down the football or whatever it's going to be. Soccer ball if you're American and watching this. It's football really, because you know it's a game, it's a ball and you kick it with your feet. Football. Anyway, I'm not going to go down there, that route, because that will just upset people. Football, not soccer. Anyway, let's get another ball of some description. Now to do this, I'm going to head down to the bottom here where we've got choose a sprite, and I could draw one. There's lots of different options here. You can upload a sprite you can get from the internet, and if you watch some of the other videos, I show you how to upload sprites, I show you what the surprise sprite does, I show you how to paint sprites. But I'm going to choose a sprite because I know in the library there are lots and lots of balls. Look, there's 3 there: ball, baseball, basketball, beach ball. I said 3, there's 4. And it goes on. So what I'm going to do is that I am going, oh, it's a flashing ball. Oh, does the baseball do anything? No. Does the basketball? No, it's the beach ball. I quite like the flashing ball. So I'm just going to click on ball here, and it's going to appear here. Now, here's the task. What we want you to do is that we want you to make this ball appear at the top of the screen when the game starts. So something that I want to introduce you to. Over on the backdrops, I'm going to pick a particular backdrop, choose a backdrop, and I'm going to grab this one, which is going to be right down the bottom, and it's Cartesian coordinates, it's known as. And you'll be thinking, what now? You may be familiar with an XY grid, but technically they're Cartesian coordinates. There's actually a few different XY grids, but I in particular like this one to explain things. The reason being, this is the x-axis and this is the y-axis. Now, let's have a look at this ball here. If the ball were to appear here, on the y-axis, if that's 0 on the y-axis and that's 180, you can see there y is 180, y is 0. So put the ball there, the ball is at x0, y0. Put the ball up there, the ball is to, let's try that again. The ball is at x0, y, well, if it was right on the edge of the screen, that would be 180. Maybe the middle of that ball's at y, I don't know, 170. But the whole point being is I want the ball to appear somewhere between here and here. So if I focus on this point here, that's x1, x is 0, my apologies, y is 170. Over here, the ball is at x, that's 240 right on the edge. If that's 0 there, and that's 240 there, I'm guessing maybe 220. So the coordinate of this ball would be x220, y 170. If I put it over here, the x would be 0 there, minus 240 there, or right, actually minus 240 is right on the edge of there, minus 220, and the y is again 170. The whole point being is that the x could be anything between minus 220 all the way to plus 220. But y is 170 there, it's 170 there, it's 170 there, it's 170 there, and it's 170 there. The y bit is not going to change. If you want to put the ball at the top, y is about 170. X could be anything from minus 220 to plus 220. So how do we do that? Well, that's the task that I'm going to leave you with a little challenge to do. So I'm going to explain the blocks that you're going to need, and then you're going to put it together. So every time you press that green flag, that ball is going to appear in a random position. So here are the blocks that you're going to need. Number 1, if we go over to the left-hand side here, events you're going to need when a green flag is clicked. Number 2, I think that ball is a bit on the big side. So I'm thinking that maybe in looks, we have the option down here to, well, do you know what? It's one of those 2 blocks. I'm not going to tell you which one. You can work it out. If it doesn't work properly for you, try the other one. It's one of those 2. Okay, but I want you to, when you press the button, that ball is going to appear to be a bit on the smaller side, maybe half its size, something like that. But what I really want you to do is under motion, we have this option here that says go to X and Y. Now we know the Y is always going to be about 170, but we know the X needs to be a random number between minus 220 and plus 220. So where do we get a little block in here to put a random number? Well, if we head to operators, There's one there, pick random. And this can slot in. Oh, I've done it in the wrong one. Look at that, it can slot in there. All I've done, and always, by the way, always grab these blocks from the left-hand side. You'll see, look, where they can drop in. So, let's just remind ourselves. You want, when the green flag is clicked, to change the size of the ball. That was in looks. One of those two is going to do it. And then you need to set it so that it picks a random number for the X, somewhere between, I don't know, minus 220 and plus 220. But on the Y, it's 170. And you'll know that it works because every time you press that green flag, the ball will appear somewhere across the top in a random position. So, that's it from me. Go and make that happen. But Nemo right off the edge there. Oh look, I got it, 180.
180!
Right, back to the tasks. Now, we have a working shark. It bites, it goes up, it goes down, it goes left, it goes right, it points in the correct direction. But now what we need to do is to introduce some fish into the game for the shark to catch. So how do we do that? Well, it's no different to how we got the shark in. Down the bottom, we can choose a sprite. A sprite is a graphic, same thing. And if you want to find a picture of fish on the internet, knock yourself out. Surprise isn't going to work because I got a boat. Might be useful actually in the game, but not at the moment. So sailboat, goodbye. And you can paint a fish if you want. Or of course, there's bound to be one in the library. Choose a sprite. And something I didn't point out last time is up here you've got like a menu system. So a fish is a type of animal. And you'll notice that there's a fish down here. In fact, there are several fish when you hover over. I'm just going to come away from it. A little bit disappointing, actually. There used to be more fish. In Scratch 2, there were like 3 different types of fish. This is just one fish with 4 different costumes. So it's like 4 fish in one. Anyway, I need the fish. So I'll click, and there it is. There's my Nemo fish. And you can see that there are 4 different costumes of fish, which is kind of fine. Right, so let's head to the code for this fish. Now, what I want to do is the following. We know that we need to do something in events. Sorry, no, I clicked on control by mistake there. When the green flag is clicked. Now you know how to make that smaller. We've already done it. So what I'm going to do is I'm actually going to do it as well. It's going to be set size 2, and I'm going to change that to, I'll take it down to 20%, something like that. I'm going to press the green flag just so I get a small fish. There we go. In fact, actually it's a bit too small. Let's make that 30. And I'll press the green flag again. There we go. Nemo's a bit bigger now. So the whole point being is this. Nemo needs to start on the left-hand side of the screen. And Nemo needs to swim all the way to the right. So I need to introduce you to some blocks. So, if I want Nemo to start on this in a particular location, I can use in motion, I can use this go to block. Now, see these numbers here, X and Y. Check out Nemo. If I move them around, it will fill those numbers in automatically. And what you can see here is that on the X, Nemo's at minus 233. Now, if I can get him right, can I get him off the edge? Minus 242. That's weird. I only thought it went to minus 240. Can I get him even further off the edge? Minus 247. I wonder if it's even possible to get him to minus... we can manually... Let's try this. Let's put him in there. Minus 260. Can I make him disappear? No, he doesn't want to like minus 260. Maybe I can minus 250 is the biggest. No, it doesn't like that either. Can't change it there by the looks of it. So, here's the thing. Minus 240, we know, is the edge of the screen. We also know that on the y-axis, he is going to be, well here, the y value is, I was trying to get it to 0, but it's 3. And up here, the y value is 172. But you can actually see that y goes up to 180, so I would put Nemo right off the edge there. Oh look, I got it, 180.
180.
So down here, right at the bottom, I wonder if this will work. Oh no, that's so annoying, you've actually got to let go of it on the canvas or on the stage. I've got minus 175, but of course it goes down to minus 180.
180.
So, the whole thing is this. The fish, Nemo, needs to go to, on the x, it's always going to be minus 240. But on the y, it can be anything between minus 180 and plus 180. So, how can we do that in there? You know, you'd need something maybe like a random function, and in the operators, oh, there's a random function. And look, we can put that in there. Look, if I do this, this is kind of cool, 1 to 100. I'm going to press this now. Look, big fish, small fish, cardboard box. Ask your teachers, they'll know what that means.
Big fish, little fish, cardboard box. Big fish, little fish, cardboard.
Big fish, small fish, no cardboard box then. But that's because I just threw that in there. Oh, didn't want to do that, did I? That'll be helping you too much. But I can put that block into there. I can put it into anywhere where it highlights in white. So, let's stop the game. What I want you to do is this. I want you to make the fish start in a random position. You know how to do that. And then I want you to make the fish move to the right. But hold the phone. When the right arrow, I've got to move this, maybe I should, when the right arrow is pressed, change x by 5 forever. We've already done that. So on the fish, what I want you to do, and this is your task, is set it to the right size, pick a random position, or make it pick a random position, and then make it swim across the screen by changing the x value all the time. Off you go. Don't forget, there's always a solution video if you can't quite get it to work. Okay, so let's make this fish randomly move all the way to the right. What I'm going to do is go to x minus 240. I'm going to pick a random from minus 180 to 180. And then when it's done that, watch this. Look, there we go. Fish is randomly appearing on the left hand side. And then what I'm going to do is grab a forever block, and inside it I'm going to do motion, and I'm going to do change x by. I think I'll change that x by, I don't know, I'm going to go with a low number 3 just to prove a point. There it goes. Mr. Fish is swimming across the screen, and he's going to get all the way to the right hand side, and then you'll see his tail. And he'll do that every time I press the green button. What I really wanted to do is then, you know, once he gets there, maybe disappear and start off again here from a random position. But that's our next task. 60 is bigger than 50. 40 is less than 50. So we've got a fish that randomly appears somewhere on the screen, and then he swims all the way across the right hand side, and when he gets there, absolutely nothing happens. Because there's no instruction for anything to happen. I'm just going to press stop for a moment. You see, the thing is, what I really want to happen is for the fish to swim across, and if he gets to that side, then go back to the beginning and randomly appear somewhere else. So he's going that way, and then maybe he comes back and he goes that way. And the whole point is the shark has got to try and catch him. So how can I make it so that if the fish gets to here, then go back to the beginning? Well, here we go. There's a command here that says in control, if. And what we have is the following. If I am on the fish and I go to motion, down the very bottom of motion, but I'll pull it to the top now, is X position, Y position and direction. So at any moment in time, Scratch knows the X position of the fish, the Y position of the fish and the direction that it's travelling in. So here's the thing. If the X value or the X position of the fish is greater than, now we know that the edge is 240. Now my fish is only changing by 3 each time, so it goes, if it starts from the middle here, 3, 6, 9, 12, I'm not going to carry on to 240, that will take a long time. But the whole point being is that I don't know the exact number because I don't know my 3 times tables. But one thing I do know is if the edge is 240, then you know the fish is going to be, once it hits 200, once it goes above 230 of the X value, it's pretty close to the edge. So what we can say is if the X position of the fish is more than 230, then go back to the beginning and start again. But here's the thing. All you really need is one operator. Now let's get this right. Let's deal with something that I have a problem with lots of students. I'm going to pull these two out here. 60 is bigger than 50. 40 is less than 50. And I think the rule in maths is, isn't it the crocodile eats the bigger number? Because look, that looks like, that looks like a crocodile's mouth, then the 60 is bigger than the 50, so the crocodile eats the bigger number. And here, the 40 is, I'm patronising, aren't I? 50 is bigger than 40, 50 is the bigger number, eat it. 60 is the bigger number, eat it. But the one thing is for sure, what we have said is that, if we just pop that back over there for the moment, so I don't want to give it to you, we want to say if the X position of the fish is greater than, bigger than 230, go back to the beginning and start again. Go back to the beginning and pick around. We already have that. Look. And you can right click and duplicate blocks. I'll put it down there. So that's my task. You're going to change this so that the fish is going to swim to the right, and when he gets to the right, he's going to randomly go back to the beginning and swim again from somewhere new. See if you can make it work. Right, to be honest with you, I think we've done enough of this game build, and I think you've already created a great working game. But now is the point in which you can go and put your own take upon this game. You can change a few things, and I'm going to give you a few ideas. Doesn't mean that they're right, just some ideas of things that you might want to do that actually don't really require any more skills than you've taught already. So for example, we have this thing where if the shark touches the crab, then we know the shark is basically going to lose a life. But maybe we could get him to switch to, back up in costumes here, maybe he can switch to that costume, costume 3 of the shark. And then maybe he would disappear and then reappear flashing, if you wanted to, between, well, roughly, well, in the middle of the screen. Maybe that's what happens when you lose a life. Maybe Mr. Shark goes to this point. That's one idea. We haven't even looked at this icon over here, sounds. I'm not even going to teach you those. They're easy enough to work out. In fact, if you used Scratch in primary school, you probably used them then. Other things that you could do. I mean, this game could go on for a long time. We've got a scoring system and a life system, but, you know, some of you kids are very good at video games. Maybe you'd never lose a life because your fish and shark game skills are so mad. Well, maybe you could have a timer. Now, I'm not going to teach you how to do that. You do need a bit of teaching. But in the other videos that I made, there's a game build called, I think we called it Mole Smash or Mole Mash or something like that. And there's a timer in that one. But the techniques in that video are exactly the same as the ones you would use in this game. So I don't need to remake that video. Just go and watch it in the Mole Smash game. Another thing that you might want to do is when we've got this fish, maybe it's saying change X by 3. Maybe you could introduce random numbers. Maybe you could have the speed as a variable and it might change. I don't know, there's nothing particularly complex about that, but maybe different fish have different speeds. Pick a random number between 1 and, well, whatever you want, 1 and 10. What else could we do? Let me have a think now. I don't know, maybe, oh, it's an idea, maybe we could introduce a puffer fish. And the puffer fish will home in on Mr. Shark. It will slowly move closer and closer to Mr. Shark. And you might be thinking, well, how do I do that? Well, actually, in motion, we had this pointing direction, but we've got point towards, and you can see that actually it can point towards any object in the game. So you could put a puffer fish or something in there, and maybe the puffer fish can point towards Shark 2, as it's called there, Shark 2, and maybe he'll just, instead of doing changing X and Y, you can use this move so many steps. And it might do that forever. Or maybe it might do it, it's got its own little timer and the pufferfish only comes in for 15 seconds and he slowly heads towards Mr. Shark, and then after 15 seconds he might flash and disappear. Again, there is nothing new to that, well, apart from the timer bit, you can learn that from Mole Smasher. But you now have the ability, you've got enough skills here that you can go and improve upon what we've made here. So that's it for this game build. I hope you enjoyed it, and good luck with your own interpretation of it. Okay, so let's finish this one off. We have a backdrop with Broadcast Live 0. We'll go to the shark, and we need, let's put all of these, oh, it annoys me, they've all come back together, and I'll overlap them all on top of each other up there. Oh, they don't want to overlap. No, never mind. So we have our, when I receive lives 0, what am I going to do? In looks, I'm going to, whoops, hide. And what I'm going to do here is I'm not going to do stop all, I'm going to put stop other scripts on this sprite. Now that's quite useful because that piece of code there, I can just go, well, put that on the fish. And I can go back to here and I can say put it on fish 2. Ooh, missed that, try that again. Put that on fish 2. And I can also put it on the crab. So now we should see it is here, but it's not here. That's annoying. I'm surprised at that because it appeared here on that fish and it appeared here on the crab. Don't know why it didn't appear on the first fish. Never mind, we should be able to grab it from there and put it on the first fish. Now it should be in there. There it is. So let's see what happens if I've got this right. Let's run it. Oh, that was lucky. 1 crab, 2 crabs, 3 crabs, game over. No scoring, no lives, all the graphics are gone, it's done. XY grid, otherwise known as Cartesian coordinates. Okay then, so you should now have a working shark. I've just hit the green flag there, and now you can see the shark is biting away. You might have different timings to me. I've gone for 0.3 seconds there, but it doesn't matter what you have. As long as you've got a shark that's biting away and is never going to stop because it's in a forever loop, then that's all good. If you haven't got that, then maybe pause the video and just sort that one out. Now the thing is, in the game, eventually we have lots of fish sort of coming in left and right and swimming around, but we don't want a shark that's that big. It's too big for the game, so I'm just going to stop it. I'm going to give you one little thing that you can include, and maybe stop this video in a second and do that, but then we're going to show you how we can move the shark around the screen. I'm going to show you sort of one way that works but that makes the game really quite easy. Then I'm going to show you another way which perhaps you might say is less effective but actually makes the game more of a game. Just trust me on this one. So, first of all, how do I make the shark smaller? Well, actually, this is really quite straightforward, because over here, where we've got the looks button here, if I click on that, then a little bit further down, we have the two buttons here that say change size by 10 and set size to 100%. Now, I've always found over the years that kids kind of get a little bit confused about which one to use. But the one we want is this set size to 100%, and I'm just going to glue that in there. So when the green flag is clicked, before the shark starts even doing any biting forever, we're going to change his size. Now if I press the green flag, nothing happens, because he's at 100% of the size. But if I were to change this to say a 50, and then I go back and press the green flag, now he's a reasonable size for the game. Now I know where this game's going to go. Personally, I still think he's a bit on the big side for where this game is going to end up. So I'm going to change that, and I should stop it first. And I'm going to change that to a 30. And I'm going to press play. Now my shark, even though it's quite a small shark, we're going to have even smaller fish, don't worry. So here's the thing. We now want to make the shark, this task is all about controlling the shark. I want to show you one way which you can do it, but to me, as I said, even though it works really well, it doesn't make for a great game. And it's a really easy one to do. But what we want to do is this. We want to say, and the reason we're doing it this way is I can introduce the fact that we can have, if I do control events even, my apologies, you can have two sets of code that run when the green flag is clicked. In fact, you have lots of different sets of code. But what I want to do is nothing more than, if I get this block here, which says go to random position, and people are thinking, what do you want that for? Well, because in random position, press the arrow, I can choose mouse pointer. And now you're thinking, oh, the mouse pointer is the cursor, so if I do this and press the green flag, Sharky's going up there because he tried to go to the mouse pointer and he's biting away. But now he's not following that mouse pointer because it only does it once. If, however, we told it to do it all the time or forever again, then actually, press it and look, Mr. Sharky is following my mouse cursor around. Now, actually, that's quite cool, and in many games that's a useful tool. But for this game, it's going to make it too easy, because the whole point is fish are going to come in from the left and right, and if you can just quickly move your shark around like that, you can go, boom, look at that, how quick. It just makes the game far too easy. So we're going to press stop here. I'm going to undo that, and I'm going to drop that over here. And then I'm going to give you options about how we're going to control this. Now I'm going to put shark back in the middle, and I'm also going to put a different stage on there just for a moment. So I'm going to add, go back to here, I'm going to choose a backdrop, and I'm going to choose this one all the way down the bottom. XY grid, otherwise known as Cartesian coordinates. Yeah, I never knew what those were either. It was only on some course of couple of years ago, and someone said, "Oh, use your Cartesian coordinates," and everyone looked blankly, and then he went, "The XY grid," and I was like, "Oh, why don't you say that then?" Because he wanted to use big words to make himself sound superior. You'll come across that in life quite a lot. Here's the shark. Here, on the orange line here, is the x-axis. And here on the blue line is the y-axis. So if I want the shark to move to the right, I need to increase the value of x. If I want the shark to move to the left, I need to decrease the value of x. If I move it that way, it might be plus 20, plus 10, plus 20, plus 30, plus 40, plus 50. If I move it this way, minus 10, minus 20, minus 30, minus 40, minus 50. The other way round is if I want it to go up, then I will be increasing the value of x. Of y. Gosh, even I got my axes wrong. I'm increasing the value of y. Look, there's a y there. I don't know. Can't even read. Y. See, he threw me with Cartesian coordinates. Dreadful man. Should never have tried to sound so fancy. Plus y, plus 10 on the y, plus 20 on the y, plus 30 on the y, plus 40 on the y, minus 10 on the y, minus 20. You get the idea. Plus x, minus x, plus y, minus y would make the shark move up and down. So, here's the thing. There are two options. Now, I have in events, I go to events, when space key is pressed. I could change that to maybe being the arrow keys. So if the right arrow key is pressed, what I can do in motion is that down here, I've got change x by 10. Now, I'm going to press go, and I'm going to hold down the right arrow. I'm going to press the, look at Mr. Sharky is moving all the way to the right. If I press the left arrow key, nothing happens because there is no instruction when left arrow key is pressed. But here's the other thing. Now, there are two ways of doing this. I could make 4 blocks when left arrow key is pressed, change the x by minus 10. I could, if I didn't want it to go so much, I could say maybe 5 at a time. Let me just show you something. If I stop this, bring Mr. Shark all the way over here, and I'm going to press play, but I'm going to hold down my right mouse button. That's how quickly he goes across the screen, just by holding it down. Let's bring Mr. Shark back. Try to bring it back. Stop the game, put him back, and I'm going to make that 10. Now to prove the point, I'll make it 15. I'm going to press play. Now I'm going to hold the right mouse button down. Much faster. So the whole point of that is how much you change x by is how fast it's going to move. In this particular case, I think I'll leave it as 5. So I could have the option of duplicating this and changing that for the left arrow and changing x by minus 5, and then I can duplicate it again for the up arrow, and I can duplicate it again for the down arrow. There is another way of doing it. The reason being is, look, when I'm not playing, the game's not running yet. The game's not running yet, and I can still move the shark around. The other option, instead of the right arrow and the left arrow, is this. Events. When the game when the green flag is clicked, I can put in a forever loop, and then I can choose an if command, and then I can choose here, it says if, and I've got this shape here, and you're thinking, well, what's that for? Well, over here in sensing, I have if key space pressed. But I could change that to a right arrow, and then I can use the same command of motion, change x by, and I put the 5 in. Now, it's a little bit more complicated, but when I press the key on my keyboard now, nothing happens. It only lets the shark move, just put him back a second, once the game has started. So I'm going to leave it up to you how you want to do it. If you prefer your shark if I just stop this for a second, to be able to move, even if the game hasn't started, fine, knock yourself out. If you prefer it that he doesn't move when the game has started, run with this one. But I want you to make sure the shark can move up, down, left and right. There is going to be a problem, okay? There is going to be a slight problem that when you move him left, he's moon swimming. To look at what Michael Jackson used to do, if you know who Michael Jackson is. He was famous that he could look like he was walking forwards when he was walking backwards, or was it the other way around? It was called moonwalking. We'll solve that in the next video, but for the moment, just make the shark go up, down, left and right. I've made a folder called Scratch Professional. Yeah, okay, that's subjective, isn't it? Now, most of the time in these videos, I'm going to set you a task to do and then there's a solution video. But every now and then we get to a little point where I think sometimes it's just easier to do a little bit of housekeeping. We'll think of it that way. Just so that there are certain things that we just need to clear up and you can just do them and watch and repeat. I'm not going to do this a lot, but there are a couple of things that I want to deal with. If you haven't watched the solution video and you've made a wonderful shark that moves around no problem, then that's great. But you'll notice that you have an awful lot of code here in the middle. So a little bit of housekeeping is that what I tend to do is, because these things about the keys, you can actually sort of drop them on top of each other. And that way it generates a little bit, well, a lot more white space. Now I can clearly see, if I just click on this one for a moment, that there are, if I stop it actually, there are 4 blocks of code here. I can see, we can all see there are 4 blocks of code there, so we're happy with that. The other bit of housekeeping that I want you to do is the following. It would be an awful shame now if someone turned your computer off, sat next to you, or you just got up and you walked off and you didn't save your work. So if you're using the desktop version of Scratch like I am here, then you're going to need to save your work. If you're logged in on the web and you're using the website version, which is identical to this, then you don't need to do this. But if you are on the desktop version, please click on File and Save to your computer. When you do that, please don't chuck it on your desktop. Okay, make yourself a folder like I've done in Documents. I've made a folder called Scratch Professional. Yeah, okay, that's subjective, isn't it? I've got one called Shark Fish, and in here I've got a game called Shark Game already, because I've already saved this one, but I've given it a sensible name, Shark Game. I'm going to press cancel so I don't need to save it over the top, but I have already saved this game. Okay, you can also press Control S on your keyboard and that will also save the game once you've saved it for the first time. So go and save your work, please.
You get the idea.
And welcome back. Now I want to deal with one little nagging problem. This problem. I'm okay with the shark moving up. I'm okay with the shark moving to the right. I'm okay with the shark moving down, but I am not okay with the shark moving to the left. What I really want to happen if the shark moves to the left is that I want to change the direction of the shark. Now, I'm going to press stop, and actually I'll put these on top of each other. I need to break them apart now. So I'm going to need the old left arrow and I'm going to need the right arrow. I'll put them down here and we'll put these back up here. Okay, I'll tidy them up in a minute. So the thing is this, when the left arrow is pressed, I want to change the direction. And in motion, fun enough, just here, we've got the one that says point in direction, and I'm going to grab that and I'm going to put that there, And you're thinking, it says 90. What does that mean? Well, if I click in the box, it basically comes up with a, well, I think it's a clock face, but it's more like a compass or a protractor. For example, here, if you know your bearings, that's 0. To go right, or point in direction going right, is 90. To point going down is 180. And to point to the left is minus 90. I think 270 would work as well, to be honest with you. But Scratch tends to work with all the way up to 180 and all the way down to minus 180. Well, actually, minus 179, I think it is technically. But what I want to do is I want the shark to point to the left, and this isn't going to work quite correctly. I'm clicking away now. I'm happy going right, I'm happy going up, I'm happy going down. Now it goes left, and it does point in direction, but it goes upside down, like a drunk shark. So why does it rotate like that? And the answer is down here on the direction. And you'll notice here I've got all around, left, right, and do not rotate. Okay, so if I press do not rotate, it won't actually point in direction. But if I choose left, right, it now does in fact point that way, and he's up the right way. So I'm happy with that. That's excellent news. I'm sure you can work out the problem. So I'm happy with it going up, I'm happy with it going down, I'm happy with it going left, but now I'm not happy with it going right. And we have the same problem, that we need a point in direction. And this time I want 90 because 90 is to the right. But you can work out the issue if I stop it and press play. If I go up, down, left and right. Oh, I was expecting to have to go and click on direction and do the left right thing again. Obviously I only have to do it the once. So now we're all happy with our shark and its movement and its pointing. So now it is a good time to cover up those blocks or dump them on top of each other, so we've got lots more white space. So this isn't a task video, well it is a task and you've got to go and do this, but there isn't going to be a solution video because there's nothing to explain. Just make sure that your shark can move up, down, left, right. It's always pointing in a sensible direction. You've saved your work and you've moved your controls for your shark so they cover each other up, so we've got lots of space to play with. Off you go. Okay then, I'm going to go for the easy option, and it was nothing more than you can actually duplicate entire blocks. Didn't teach you that. I wonder if you might, those people that have done it already and they say, oh we've done it, I wonder if they knew about it. So those of you that use the solution video, you've got a bit of an advantage here. Look, you can duplicate entire blocks. So all you have to do here is then go, I'll make that the left arrow and I'll change the X by -5. Job done. And when you're happy with that, you could duplicate that block. And you can say, I'll press the up arrow and I will change, not X, that one needs to come out, change Y by 5. And then we can duplicate that one, pop that there. If they press the down arrow, we can then change the Y by -5. How cool is that? And now, when I press my green flag, I have a completely, pressing the keys now obviously, moving shark. I'm not happy with this moon swimming going back, we'll deal with that in the next video, but everything else is I'm quite happy with that. So there you go, go and make sure that you've got, make that happen. And then what I tend to do is I just tend to just put these on top of each other, like so.